This video is going to be all about 2.7 nonlinear inequalities. Nonlinear inequalities are just like regular inequalities where we had like x is greater than 6 or something like that, except we want it to be equal to 0 to kind of give ourselves an interval which we can test things. So if I just want to make my first step as to set this to 0, then I would need to move over my 36 so that I would have x squared minus 36 is less than 0. So I don't really know my zeros, but I know I have 2 of them. So I'm going to say the next step is to factor this thing if we can. Well, I see that there's a difference of squares, so I have x minus 6 and x plus 6 is less than 0. So then I know my zeros are going to be x equals 6 and x equals negative 6. If you want to put plus or minus 6, that's fine too. So then what we have to do with these are called critical numbers. Critical numbers, C-R-I-T-I-C-A-L. C-A-L, yeah, something like that. Critical numbers. Okay, they are very important, so they are critical. Okay, we're going to be dealing with negative 6. We're going to be dealing with 6. We are simply less than, so both of these dots are open. So we cannot equal those numbers. So what I'm going to do is to test these intervals and see which one this is true, I have to be less than. So I'm looking for negative a solution. So say I pick a number like negative 10. If I put in negative 10 minus 6 will give me a negative number. Negative 10 plus 6 will also be a negative number. So when I multiply two negative numbers together, they will be a positive number. So I do not want that interval. If you want to, sometimes kids like to see the dots kind of split up the intervals, so I know I have to test something in here and something in here as well. But I know already that that interval does not work. Well, now pick something in the middle. Pick something between negative 6 and 6. 0, if you can pick it, is always going to be the easiest one to pick. Because then it's just your numbers. Negative 6 times 6 is a negative number. So then that interval will work because this is a negative interval. So I know I'm going to have from negative 6 to 6. And then just check your last interval. Say we choose 10. Try to pick easy numbers. 10 minus 6 is a positive number. That'll be positive. Positive times a positive is a positive. So I don't want to pick that interval either. So then for your solution interval, you write everything from negative 6 to 6. It's kind of similar to your domain. Okay, we have everything from negative 6 to 6. They're both open, so they're both open in my interval set. Here's another example. This one, it's already set to 0. I can't really factor anything, and I have a fraction minus a whole number. Well, in order to do a fraction minus something, I need to have it to the same denominator. Right now I have an x and a 1, so to make this the same, if I multiply my 4 by x over x, then this will be 1 minus 4x over x, since they have the same denominator, is less than 0. And now that I have an x on bottom, I know that x cannot ever equal 0. So there is one of our critical values already. For the other ones, we just look at the zeros of the function. So to look at the zeros, remember this is just like when we were doing rational functions. You're just going to take the top, set it to 0, so 1 minus 4x equals 0, and solve. So minus 1 divided by negative 4, so x will be 1/4. So we have the critical values of of 1/4 and of 0. We're going to have to test both of those points on your interval. And once again, just like in the last problem, we have our function is less than 0, so we are going to be looking for negative numbers. So I have 0, I have 1/4, and I'm looking for negatives. 0 is open because I cannot have it. 1/4 is also open because it's just less than. And just pick some numbers less than 0. Say I choose negative 1. Well, when I put in negative 1 minus 4 times negative 1 will be 1 plus 4, which is 5 over negative 1. So that one will work because that is a negative. So I can shade all the way up to so 1/2 won't actually work. I tried to just erase that and it didn't let me do it, so this program's kind of silly. But now that we know that 1/2 will work, since it's bigger than 1/4, then we did that. That's cool. Sorry you guys, I apologize. So 1/2 will be over there, and that will work. Let's try to get my interval back. So something between 0 and 1/4 would be like 1/8. Whoa, I don't want a highlighter, sorry. So if I choose 1/8, 1 minus 1/8 of 4, well, 1/8 of 4 is 1/2, so 1/2 over 1/8 will be a positive number, and that will not work. So I have everything between the interval negative infinity all the way up to 0, and then from 1/4 to infinity. That is how we would write our notation. In problems like number 57, it gives you a square root and it's asking for the real domain. Well, if we have the domain of the square root and it's real, then we know wherever it is, it has to be positive, so it has to be greater than 0. So what I can say is that I have to have x squared minus 7x plus 12 greater than or equal to 0. It'll make it way easier to solve your square root. So then it's just a matter of factoring. So I have x minus 3 and 4 is greater than or equal to 0. There are our critical values, our critical numbers, x equals 3 and x equals 4. So I can write my interval already. I'm dealing with 3 and I'm dealing with 4. And in this case we are greater than, so I'm going to be looking for the positives. We are also or equal to, so I can go ahead and fill in those dots. Yeah. Yeah. You can write bananas on them if you want to too. So if I'm dealing with 3 and 4, to test those intervals, pick something less than 3. Say we choose 0. You're okay. So if I plug in 0, negative 3 times negative 4 is a positive number. So there we are, good to go. Choose something between 3 and 4. Let's do 3.5. So this will be positive, this will be negative. Positive times negative is a negative. So no, that interval will not work. Then pick something bigger than 4. Say if we choose 10, that is positive. This will be positive as well. Positive times positive is positive, so we're good to go there. Then just don't forget to write your interval from negative infinity all the way up to 3. This time put a bracket around 3 because it is included. We can equal 3. Then from 4 to infinity. Bueno.